Hi everyone. Thank you so much for joining me here today for our session. During today's session, I'm gonna show you how to build a multi-agent nutritional application using CrewAI, Llama 3.2, and Gradio. My name is Haley. I am a data scientist with the IBM Skills Network team. And like I said, I'm gonna guide you through how to integrate these tools together to create our intelligent scalable application. So here is an overview of what we're going to cover today. First of all, I'm gonna give you an overview of our application so you know exactly what we're gonna have by the end of the session. And then we're gonna go into the core concepts behind multi-agent systems and their components. And then for the rest of the session, I'm gonna give you some time to actually do a hands-on lab so that you can build the app yourself. And then finally, we'll wrap up with some key takeaways, and then I'll open the floor for more questions and answer if you have any. So before we actually start, I just want to give you a few key reminders. Like I mentioned before, this session started with the presentation, and then the rest of the session will be the hands-on lab. I plan so that we have 30 minutes for the lab. Um, so it might be less or more, and don't worry if you cannot finish the lab by the end of the session. You can always go back to cognitiveClass.ai later after the session finishes to pick up where you left off. And I walk you through how to sign up and then enroll in the lab and have an account and everything. And then during that whole hands-on lab session, if you have questions, I'm here to help you. So don't hesitate to ask. And then, like I mentioned before, at the end, there will also be like a 5 to 10 minutes Q&A time just for questions. And with that out of the way, let's begin. So first of all, like I mentioned before, I'd like to give you all a quick overview of the application. So this application, I call it the Nutri Coach. I'm gonna play a little video to show you how it works. So for this app, it has two functionalities. The first one is that the user can upload a picture of the fish content, and the fish contents will have like food items like this, and then the user adds dietary restrictions, and then they select the workflow type as recipe, and then they will click analyze. Then the application will show some recipe suggestions that adheres to the user's dietary restrictions. And then the second use case of this application is that the user can upload a picture of a complete dish, and then they will select workflow type as analysis. Oops, sorry, as analysis, and then click on analyze. Then the app will then analyze the image and gives a breakdown of what is the name of the dish along with some total estimated calories, nutrient breakdown, and you will also see like a brief health evaluation of the dish. So that's how our app is gonna look like. I hope that gives you a little bit more motivation to follow through to the end of the session. Now to go into the core concepts of the app, we are going to start with agentic AI and multi-agent system. So if you have attended the previous sessions in the morning, I'm sure you have heard a lot about agentic AI and multi-agent system. Here, I'm just gonna quickly recap what these are. So an agentic AI refers to systems that operate with autonomy. They can make decisions, interact with the environment independently. These systems solve problems or achieve goals on behalf of the user. And they often use advanced AI models like large language models or reinforcement learning models. So, for example, you can think of a virtual assistant like Siri or Alexa. It listens to your request, processes it, and independently retrieves information or performs an actions like setting a reminder or tell you about the weather. On the other hand, a multi-agent system or MAS is a system where multiple autonomous entities called agents work together to solve a big complex problem. So each agent in the system specializes in a task, but collectively they work together to achieve the goal. And so they mimic real world collaboration. So, for example, you can think of a restaurant where there's a chef preparing meals, there's a wait staff serving customers, and there's a manager coordinating everything. So in that restaurant, everybody has their specific role, but they work together to give the customer a good dining experience. So if you attended the BAI framework and also the keynote session, you have B and CrewAI. They are both multi-agent systems. And in this session, we use CrewAI. And so here, just to solidify our understanding, I have an MAS example of a game builder crew. So the goal of this group is to help the user build a game. So as you can see here, you have this user who's gonna give the input instructions to the group. Let's say the user wants the group to build a specific game, let's say like a Pac-Man game. Then the user is gonna give that instruction to the crew. And this here is our AI group consisting of 3 agents. This group is gonna work together to finalize the code at the end, and then when the code for the game is good, it's then gonna return the output to the user. So now that you have heard about Agentic AI and MAS, you might wonder what is the difference between them because they sound kind of similar to each other. So the main difference between them is in collaboration. So Agentic AI focuses on a single self-sufficient system, whereas MAS relies on a shared system and collaboration between specialized agents. And as I mentioned before, in this session, we focus on MAS because it is more ideal to handle complex workflows. So now that you understand the highest level of the concept behind the application, let's go a little bit deeper into each component of MAS. We are going to start with the first component, which is the agent in MAS. So an agent in MAS, you can think of them as the worker in the system. So like in our restaurant example, there's the chef, there's the wait staff, there's the manager. And like I mentioned, each of them is autonomous and each of them specializes in one task. They work independently, but they talk with each other and they rely on each other output to do their job better. And then again, if you had attended the BAI framework session, you would know that like agents in a multi-agent system, they can think before they act, or they are commonly known as react agents. So what does react actually mean? So the re in react stand for reasoning, and the act is acting. So reasoning means that the agent stops to think about what it needs to do based on the information it has. And then acting means that the agent takes the action after it finishes thinking to decide what to do next. And the agent will repeat this process multiple times until it reaches the best result. So I have a little diagram here to show you the thought process of the agent. So our agent is this little robot here, and then we have the context, which is the input in this case, is gonna go into the agent, and then here the agent is gonna think about it a little bit. After it finishes thinking, it will decide what tool to use, and then it will take an action. When it finishes the action, it will produce an output, and then the output will go into the agent's observation. And then at this step, the agent will either decide that the output is good enough to return to the user, or it will decide that it needs to refine the output more, so then it will repeat this cycle again until everything is perfect. So then, to put everything in similar terms, you can think of React agents like a detective, right? So if you have like watched detective shows or movies, you know that they don't just arrest anybody because they found a clue, but instead, first they look at the clue, and then they investigate or ask questions based on that clue to get more information. And then after that, they will think again to get more information. And then finally, they solve the case after carefully reasoning and acting multiple times. And so I hope with that you have a very good idea what agents are in MAS. The next component of an MAS are the tasks. So the tasks are the building blocks of an MAS. So each task is a small specific jobs assigned to each agent. So together, the tasks form a workflow to complete complex operation. And as with any task, it will take in input data and produces output. So to continue on with our game builder crew example, here I have another diagram to break down even more of the task of each agent. So again, we have the input, and then we still have our three agents here. But in this diagram, you can also see the tasks of each of them. So for the game developer, they have the coding task. The game tester has a review task. And then finally, the gameplay experience evaluator, it has the evaluate task. So each of them will do their own task, produces an output, and passes it on to the next one. And for the last agent, it will decide whether the final code looks good. If it looks good, then okay, we will output to the user. If not, the whole workflow will continue again. So I mentioned about workflow a lot, and I think at this point you can have like a good idea of what it is. So the workflow is nothing but the roadmap that connects all the task and the agent together. And the workflow defines the order of the task, and it ensures that the tasks follow a logical order, and it allows the agent to reason dynamically within the task while following a larger roadmap. So here again, our game builder crew example, this is the whole workflow. We have the input, we have the whole crew working together, following the arrow for the correct flow of task. And then at the end, we have the output. And then here, I have an example of what the workflow actually looks like in the terminal. If you had already attended the BI session, you will see this looks a little bit different than BAI, but don't be alarmed. I will explain to you what these are. So this is the workflow of CrewAI in the terminal. When you run the example, it will start off by saying, "Welcome to the game crew," to let you know that the crew has started working. The first agent in the crew is a game developer. And first, it will reiterate its task to let you know what it's doing. So in this case, its task is to create a text-based RPG game using Python and integrate with Gradio interface. And then here it tells you again the instructions that it was given, which was given to it by me when I ran this code. So this instruction is nothing but the input that the users give it. So for the game, it has a game overview, the core game elements, the gameplay mechanics, and game storyline. So when we run the Crew, you will see that the game developer goes over the instructions for the task, and then at this step is produces the final answer, which is the code for the game. When it has the code for the game, it passes on to the next agent, which is the game tester. And the game tester has the task of reviewing the code that was given to it. And then here again, we see that the game tester finishes reviewing the code, and here is its final answer. When it has the final answer, you see that it moves on to the last agent, which is the gameplay experience evaluator. This agent again goes over its task and its instructions, uh, and it keeps reiterate until it is sure that the code looks good. And when everything is done, you will see in the terminal something like this in black text instead of green, and it will tell you that here's the result, and it gives you the final code for the game in full. So with that, hopefully you have a good idea about the workflow and the task in MAS. Next for tool calling, we're gonna go over tools and tool calling. Sorry, give me a second. Sorry. Okay, I think we're good. Okay. So here, tools are like gadgets that a spy uses.
Hillary?
Sorry.
We lost your screen. Can you reshare it? Perfect. Thank you.
Thank you. So start. Okay. We're still good?
Yep.
Okay. So for tools, you can think of them as as gadgets a spy uses to complete their mission. For example, in our NutriCoach app, one tool might filter ingredients based on dietary restrictions, while another generates recipes. Tools are defined in the CrewAI as reusable modular functions that perform specific action. So how about tool calling? So tool calling is nothing but the process where an agent dynamically decides which tools to use based on the task it's performing. Um, Tools are called dynamically based on the agent's reasoning process, and this tool calling process forms the backbone of any multi-agent system. Sorry. Give me a second. Let me just turn the cameo off so it's not blocking the screen. Okay, that's better. So like we went over multiple times already. How the process work is that each agent, when it receives the input, it's just gonna evaluate the current the state of the task, and then based on that, it will decide which tool to call to move closer to completing the task. And then when it finishes the task, it will produce an output, and then it will decide whether the output is good to move on to the next step, or it needs to refine the output again. And with that, let's move on to CrewAI and understand what it is and how it can help us building our application. So if you attended the keynote session again, CrewAI is a multi-agent framework that manages and orchestrates the agents and tasks in our app. So It helps ensure that all the tasks are executed in the right order, the workflow is respected, and that the right agent has the right task. And also, it helps the user or the programmer handles inputs, outputs, and dependencies between tasks better. So, in similar terms, you can think of CrewAI as the director of a movie, and agents as the actor. The tasks are their roles, and the tools are their props. So, CrewAI is there to ensure that everything runs smoothly by coordinating agents, assigning tasks, and handle outputs. And with that, I'm gonna show you an example that's more relevant to our application. Here is a simplified overview of one of the groups in this application. It is called the NutriCoach recipe group. This is the group that handles generate recipes. So you can see here it is a simple workflow where the input is the image, and all these agents are our group. So we have the vision agent, the nutritionist agent, and the recipe agent. They work together to produce the recipe at the end. And I want to take some time to go a little bit more in depth in the workflow to help you understand how the group work together. So let's say you as the user has an input as an image here, and then you give it to the app. And the first agent in our group is the vision agent. This agent has two tasks. It will first analyze the image, and then it will extract the ingredients from that image. And then for this agent, we are using the Llama Vision Instruct model. I will go over this one a little bit more later to help you understand what it is. When the vision agent finishes its task, it will have a list of the ingredients from the image. It will then give that output to the next agent, which is the nutritionist agent. This agent has only one task, which is to filter the ingredients based on the dietary instruction restrictions input by the user. And then for this agent, we are using the Granite 3.1 model. After this agent finishes its task, it will produce the output, which is the filtered list of ingredients, onto the last agent, which is the recipe agent. And this agent has also just one task, which is to generate recipes. And for this agent, we are using GPT-4 model, which is the default model for CrewAI. And when the crew finishes all of the tasks, the user will then have a recipe at the end, which was shown in our application at the end. So that kind of wraps up on our small session on multi-agent systems and all of its components. Now we're going to look at multimodal AI and more specifically the Llama 3.2 Vision Instruct model. So I know some of you might have attended the Llama 3 stack session earlier, so they may have mentioned this. But multimodal AI, the multimodal here is refers to the ability to process and integrate information from multiple modes or types of data. So the modes usually include text, images, audio, or video, and these model will combine insights from multiple sources to enhance reasoning and produce one output, which is the text at the end. So here I have like a little diagram to show you the key components of a multimodal model. So first we have the input module. Here you can see that it has different types of data. It will go into what is called a fusion module. This is module, not model. Sorry for the spelling mistake. This fusion module will then integrate the different types of data together. So let's say in this module, there are submodules, and each submodule will handle one type of data. And then at the end, it will integrate all of the output of those submodules to create the output for the model. And the Llama 3.2 Vision Instruct model is a multimodal model, which has capabilities to accept visual and text input data from the user. And this model is from Meta. So that I hope you have a good idea of what multimodal is and why we need it for this app, because we need something that could help the application understand an image and then extract the list of ingredients and then produce recipe at the end. Likewise for the nutritional analysis of a dish. So this is why we are using Llama 3.2 so that it can help us on that step. And lastly, we're going to touch on Gradio. Maybe I think some of you might already know Gradio is an open source library that simplifies creating user-friendly interfaces for machine learning application. So with Gradio, you don't have to worry too much about the front end of your application. For example, if you're building a Flask application, you have to worry about defining your HTML file and then your CSS file. For Gradio, the front end is already pre-made for you. You just have to import it and then integrate into your main application file so that it's easier for you to produce and deploy the application. And that is pretty much all I have for the technical concepts of the application. Now, if you can, let's try to set up the lab so you can actually work on it on your own. I'll be here. So you can either go to cognitiveclass.ai and then search for this project, or you can just input this link on your browser or scan with your QR code, however you refer. And then I will give a little bit of time for everybody to set up. And I believe that Ricky, who is my teammate, also just leave the link to the lab in the chat as well. So the link is ibm.biz/NutriCoach. If you don't have the link, you can refer to the chat for the link, because I'm gonna stop the slideshow for now to show you the actual lab. So when you enter the link into your browser, you will be taken to this page on cognitiveclass.ai, and this is the guided project for the lab. It is called Agentic AI. It's the same name as this session, build a multi-agent app with CrewAI and Gradio. So if you are not familiar with cognitiveclass.ai, you will have to make an account in order to access the lab. So here you can click on enroll for free. Then you will be taken to a page like this. So if you don't have an account, just simply switch to register and then take some time to create an account for free. Or you can register using one of these methods. For me, because I already have an account with IBM, I'm gonna use that to access the lab. If you have any issues setting up the lab, just um, send a message in chat. I'm monitoring the chat as well as my team members, so we'll be able to help you. Okay, so when you finishes registering or logging in, you will be taken to this page. It might look a little bit different on your end because for me, because I'm staff and also I'm the author of this, so the scene may look a little bit different. But in any case, when you are enrolled, just go on to begin course, I believe. You will be able to see a page like this where it introduces you to our Skills Network Labs Cloud IDE environment. And just scroll down to the bottom where it say launch your project in Cloud IDE and click on that button. And then just click OK. Then you will be taken to the actual lab. It will take a while for the lab to finish setting up, but please be patient with it. You can either use Firefox or Chrome, whichever is better for you, but I would recommend using the most current version so that everything runs smoothly. I am, let me try this instead. Okay, so after a while, we have our lab here. So if you have never taken a guided project or a lab on cognitiveClass.ai, you might be a little bit overwhelmed by this scene. So this is just how our Cloud IDE is set up. On the left side, you have all the instruction for the lab. And then on the right side here, this is the actual Cloud IDE environment for you to like write your code and then run your code. So like I mentioned before, if you cannot finish this lab by the end of the session, that is totally okay. Now that you have access to cognitiveClass.ai, you can always log back in and refer to this lab whenever you have more time to finish it. So I'm not gonna read everything here. This is just the intro page for the lab and some disclaimer and a little bit of like recapping what we're going to build, what we are going to use, and some disclaimer that we have to be careful with the recipe output at the end. And then also you have the video of what the application actually looks like again here. So you remember what it's capable of. So the first page is just introduction. And then on the second page, I have some tips for the best experience. I highly recommend everybody to actually read this page and refer to it whenever you have issues in the lab. You can quickly refer to it by clicking on this hamburger button on the top left. It is the table of content. When you click on it, you will have a breakdown of all the pages in this lab. And the page that is, I think, one of the most important in this lab, the tips for the best experience is page number 2. So you can always click on it to refer back to this page. So in this page, I'm just giving you some tips on how to navigate in Cloud IDE, how to run the code. And then whenever you have issues, what you can do to help you fix that issue quickly. One of the issue, like a lot of you might have encountered already, is that sometimes it doesn't load or it gives you an error while trying to run the application through port 500. To fix that, you can just refresh the app. So I'll leave you to read that on your own for a little bit. The second to last most important page is this page, which is the quick version. So again, you can refer back to this by clicking on the hamburger button on the top left. So on this quick version page, this is intended for anybody who just want to get the code for the final application without having to go through um, all the learning materials. This is only recommended if you already know CrewAI multi-agent system, um, Llama 3.2 pretty well. If not, I don't think you'll get a lot of knowledge from just getting the code, but if you're in a hurry, just feel free to use this option as well. So here I walk you through the steps to set up the application in the Cloud IDE environment. So I'm gonna go over the steps right now. So the first step is to clone the project's GitHub repository. To run a code block in Cloud IDE, you can just simply click on this button. It say execute. When you do that, you will see that all the code got sent to the Cloud IDE environment on the left. On the right. When you see that the cursor is returned to this black rectangle, it means that the code block has finished executing and you can go on to the next step. So the second step is to set up a Python virtual environment. Again, I have already set up the code block for you. All you have to do is click on this execute button and it will run the code. So again, when you see the rectangle returns to this blue text, it means that the code block has finished executed. Sorry, I have a question from Natalie from the chat. I'm sorry, I think I don't know your gender, so I'm gonna say he or she said, I have a specific use case in mind for Llama 3.2 and was wondering where I can submit or discuss it for review. Could you kindly direct me to the appropriate channel or provide any submission guidelines? Um, for this, I am not quite sure what is your intention, like whether you want to build an application or you want to write a tutorial or blog post on it, or if you want your lab to be published on cognitiveGlass.ai. If you want it to be published on cognitiveGlass.ai, you can try send me an email later and I will ask my manager what we can do about it. But if you just want to write a tutorial on your own or build your own application, feel free to do it at your own convenience. And I will give my contact information at the end of the session, so don't worry about that. Okay, so going back to our lab, we have finished setting up the virtual environment. The next step is to install the required libraries. And again, you just have to run this code block. So this code pip install is gonna install all the required libraries in a document called requirements.txt. If you want to see what it looks like, go to File Explorer here, and then select NutriCoach here, and then here the last document is called requirements.txt. Double click on it, and then you should see it on the Cloud IDE on the right. So these are all the packages that we are installing for the application. So the most important applications for the app are CrewAI, Gradio, IBM Watson X AI, because we are actually using all the supported models offered or hosted on IBM Watson X AI. And CrewAI has just recently formed a partnership with IBM, so this is why we can use the models from Watson X with CrewAI without having to get an additional API key. Oh, another thing I forgot to mention, in the Cloud IDE environment of the Skills Network, you don't have to worry about the Watson X AI API key because the lab has been set up so that you don't need those credentials. But if you are using this code outside of this environment, then you will need the API keys. Okay, while that is running, I have another question from Ahmed. How does CrewAI ensure that tasks are assigned and executed by the most suitable agent within the workflow? So for CrewAI, everything is pretty decided by you. So after I finish this step on setting up the app, I will show you about the group.py file. In that file, you design your own group. So you decide this group is gonna have this agent, and then for each agent, you also decide what task it's gonna have and what tool it's gonna use. Um, so the requirement has finished installing. So now to run the app, you just click on this again to run the app. And let's say it's gonna take a little bit. Okay, once it finishes running, you will see a message like this in the terminal where it say client successfully initialized and that the application is running on local URL, etc., and that the HTTP returns code 200. Everything is okay. So that's when you know that the app is up and running. And to run it, you can click on this purple button here where it says web application, or if you want to, on the Cloud IDE side, that this button at the end where it says Skills Network Toolbox, you will click on it, and there's the Launch Application button. Here you will then put application port 500 and then click your application. Then it will be launching your app here. So while the app is loading, getting back to Ahmed's question about designing the crew and make sure that everything works, in the source code, if you go to crew.py, here is where we are designing our crew. So for example, this is the base NutriCoach crew. As you can see here, I define the agent, and this agent has these tools. And then when you go to the task where I define the task, in the task, you decide that this task is given to this agent. So everything is very much by choice and by your own design, what you decided to do. So another question for Ahmed is, how does CrewAI handle task failures or unexpected outcomes from individual tasks or agents during execution. So I don't have a visual example to show you, but if you remember, I show a slide with all the green text where the CrewAI runs in the terminal. So usually when something goes wrong, there will be a block of red text during the workflow of the agents to describe exactly to you what the error the agent has come across. And based on that error, you can try to find a solution. So each time is a little bit different. It could either be that, let's say an agent is trying to use a tool that is not given to it, and it will keep reiterating multiple times, and it will crash because it's like the maximum number of iteration has reached. It will stop the workflow, and it will return like an error message in red to you as the user to understand the error. So here, so one of the thing about Cloud IDE is that sometimes it takes very long for the application to load. So if that is the case for you, don't worry, just click on this reload button here. Sometimes it takes some attempts until the application is set up. So here I'm gonna do it again. And it will also take a while, so Holly, if there's another question I can answer while waiting. So somebody said, I can't find the NutriCoach project folder in the project directory. What can I do? So if that is the case, first of all, I'm gonna add a message in the chat. So first of all, I would like you to type, oh, okay. Okay, so it looks like one of my team members helped me answer that already. But let me see if I can open another terminal. Okay, so for that question about you are not in the right location for the app. So first of all, you should try pwd. So that is a like line command to decide where you are in the folder. If you are in something called home/project, then I would like you to do ls to make sure that the NutriCoach folder is there. When you see that the NutriCoach folder is there, do cd NutriCoach. But only do these steps once you have cloned the repository. If you did not clone the repository, then the folder will not be there. So you have to follow this page by the order that I have put here. Anyways, so our application finally finishes loading. So here, as I showed you before, this is our AI NutriCoach, and it looks pretty much the same as the video. Here we have some examples. So anybody who wants to try the app can just quickly click on it. In this case, I click the first image for vegan and recipe again, and then I click analyze, and then it will take some time for the app to run. So going back to my question about how we know when the CrewAI comes into error. So here in the terminal, when you click analyze on the app, you can see the workflow in your terminal. It looks pretty much like what we saw for the game builder group. So first we have the vision AI specialist. It will have like a thought process where is thinking about what it needs to do. So in this case, it's saying that I need to detect the ingredients from the uploaded image from using an advanced vision model. And then it will decide that this tool, for this task, it will use the extract ingredients tool, and then the tool input is our uploaded image, and finally it has the tool output. So Ahmed has another question. What are the computational and storage requirements for deploying multimodal AI at scale? For that question, I'm really sorry, but I don't have the answer on hand with me right now, because so far I have used mostly Llama 3.2 Vision Instruct model, the 11 billion parameters, and deploy it using Gradio on. So if you know about Hugging Face spaces, they offer a place for you to deploy your model using Gradio, and they have some like free options for computational and storage already up there, and is pretty good for an application like this. Like an application like this, I can deploy via Hugging Face spaces without paying anything. So even though I don't know the exact answer to your question, I believe there are options out there that allow you to deploy these with little to no cost at all, especially Hugging Face. Okay, so during that time, it looks like our crew has finished its task. So if you look in the terminal, we can see that the Vision AI specialist decide the list of ingredients from the image, and then it passes on to the next agent, whose filters the list based on the user provided vegan, and then it will have a filter list like this, and it passes on to the recipe generation specialist. And then we have our recipes at the end, and on the application, you will also see this in the result part. So let's look at one of the recipe. It say that I can use apple, which is present in the image, blueberries, yes. For the oats, I'm not sure. I think it mentioning maybe that the user can find the oats by themselves, and then we have either water or milk. So there's like a jug of milk here, but we're not sure what type of milk it is. And then maple syrup optional. So as you can see, like the main ingredients are pretty much from the image, but it also has some extra ingredients that it assumes that the user might have on hand. So this is why on the intro page I added a disclaimer that always verify outputs of Gen AI models to make sure that everything is correct. And then when you finish playing around with the app in the Cloud ID environment, just do Control C. The instruction is also available on the left side. When you do Control C, you closing the app and closing the server. And then with that, if you just want to have the app running in 10 minutes, that is it for you. You completed the project, you got the code, or you can like study the code later if you want. But if you want to actually getting into the learning materials of the lab, I suggest that you continue from step 4 until the end. Um, in each step, I make sure to explain all the concept well, so that you will understand it even though you're not very familiar with multimodal or CrewAI. For example, there is a part for you to learn more about Llama 3.2, and there's also a part to reintroduce CrewAI and multi-agent system to you again. And then for each step, from understanding our agents, our tasks, everything is written in depth in the lab. So feel free to explore them at your own convenience. Okay, so a question from Natalie. Just for comparison, can you kindly explain the comparison from using OpenAI ChatGPT Vision is it model? So in this application, let me show you the agents. Mm, Actually, let me go back to the slides where I have the agent. Um, so in this application, the vision instruct model we are using is from Llama 3.2. This is a multimodal model. It accepts like image and text. The difference between OpenAI ChatGPT Vision and this is just the model itself. Yes. So for ChatGPT, I believe O1 is also a multimodal model. It also accepts image and text. They are built differently, and I think each of them might have different capabilities. To understand more about their differences, you might have to read more on the published research paper when they build these models. But in general, I'm using Llama 3.2 because it's the only multimodal model hosted on WatsonX.ai at the moment. So it's free for us to use in the lab environment. If you want to use the O1 model instead, then you will have to get the OpenAI API key yourself and then put that in the lab and then try it out to see what is the difference between the models. And I see that I only have 3 minutes left for the session. So I just want to quickly recap on the takeaways for this session. So in this session, we went over multi-agent systems, which enable scalable and modular AI solutions by breaking tasks into smaller manageable components. We learned about CrewAI, which simplifies the creation and orchestration of MAS. We understand tool calling, that this is the process of an agent deciding which tool to use to carry out and finishes its task. And then we also touch a little bit on multimodal AI, which is a type of model that accepts multiple modes of data types in its input, and it creates an output in single mode, which is text. And I hope that now that you have the lab on hand, you will have a foundation to explore more about multi-agent applications with CrewAI and also try to incorporate multimodal AI in your application. And here are the team members that helped me either build the slides or review my lab. So thank you very much for all of them. And these are our contact information as well. Just for the purpose of this lab, please only send me email instead of everybody. So my email is as seen on the screen. Ricky, if you can send my email in the chat, that would be appreciated. Okay, one last thing that I want to ask you as a favor. I promised one of my team member this. So in cognitiveClass.ai, we just introduces something called a learning path. So if you are familiar with Coursera, edX, you know that like sometimes you can like make your own learning path. So we kind of have something similar, which is our personalized learning plan. Um, so for this, you can log into cognitiveClass.ai under My Learning. If you click on My Learning, you have the option to create a learning plan. And here, you can actually build what you want to learn, what you want to study, add them into your plan, and then try to finish it within your set goals. If you have the time, it would be truly appreciate it if you can like try out this feature and like email me if you have any feedback, if you have anything you think should be better, can be improved. My email is again, I think, in the chat. Yeah, so Haley dot QUACH, which is my last name, at IBM.com. If you have any leftover questions from the lab, any questions from this session, any feedback for the personalized learning plan, feel free to email me. I will try to answer them or ask another team member or my manager for help. And I think with that, that is the end of my workshop. Thank you very much again, everyone, for attending this. I hope that it gives you a little bit more understanding and then foundation of CrewAI multi-agent system. I think these are very cool tools and you can do a lot with them. You can see more examples on the CrewAI GitHub repo. They have multiple examples of pre-built crews. So you should explore them and also try to build your own groups like what we did in this lab to make your own application. And yeah, that's it. Thank you so much. Have a good rest of the day, and I hope you will enjoy the other sessions as well.